Hello JPJ Discovery followers, welcome to another video. In our solar system there are moons with frozen volcanoes where ice flows like lava. The surface of Saturn's moon Enceladus is a wasteland where temperatures rarely rise above -200 degrees Celsius. Near the southern pole the ground rumbles before a great volcanic burst erupts through the ice. But it's not lava, it's water. Enceladus, like many of the icy moons of the solar system's outer planets, plays host to cryovolcanism, the seemingly contradictory term for volcanism that occurs many hundreds of degrees below freezing. While this frosty geology is also thought to take place on several dwarf planets such as Ceres and Pluto, the solar system's icy moons have shown planetary scientists what drives cryovolcanism. Cryovolcanism wouldn't be possible without a liquid layer under the crust acting as a mantle. The idea of a planet with cryovolcanic activity had never been considered before the Voyager missions, as it was thought the icy moons would be frozen solid. They are so far from the sun that their surface temperatures are several hundred degrees below 0 degrees Celsius, and all the residual heat, the thing that keeps our own planet's mantle from solidifying, should have dissipated. Without a mantle, there can be no volcanism. What planetary scientists didn't account for, however, was the tidal tug-of-war between the various moons and their planet. This gravitational pull flexes the moons, keeping layers moving and preventing them from freezing completely. Instead of being frozen, these moons have liquid water oceans dozens of kilometers deep, sandwiched between the icy crust and a rocky core. In most cases, it is possible to identify the presence of such an ice layer by looking at the moon's magnetic field. As the oceans contain some salts, they act as a conducting fluid, and their motion can affect or even create magnetic fields. These fields can then be monitored either directly from orbit by a spacecraft or indirectly by watching their aurora. The very idea of a frozen volcano is so strange that it was never even considered a possibility until the Voyager missions in 1979. While flying past the moons of Jupiter and Saturn, the two spacecraft sent back images that looked very familiar to terrestrial volcanologists. They showed smooth lava plains, volcano-like mountains, and craters. Scientists analyzing the images asked themselves whether this was some bizarre, frigid facsimile of the volcanism we know so well in the inner solar system. But the real smoking gun came in 1989, when Voyager 2 flew past Neptune's moon Triton and saw a plume of water rising 8 kilometers above the surface, an icy eruption gushing from a mantle of liquid water beneath the surface. But the Voyager zipped by their targets, giving only a tantalizing glimpse of the worlds they passed. It wouldn't be until Cassini began orbiting Saturn in 2004 that we got our first real view of a cryovolcanically active world. When Cassini arrived at Enceladus, it found evidence of a liquid layer hiding underneath the crust, which was acting as a mantle. Later, images taken from Cassini's imaging science subsystem confirmed the presence of jets coming from the moon's surface, and it was clear that liquid water was bubbling up from a layer under Enceladus's crust. A similar cloud was seen coming from the south pole of the Jovian moon Europa in 2012, showing that cryovolcanism can be found throughout our solar system. On Jupiter and Saturn, the lava is mostly composed of water with some ammonia and salts, but not many other water-soluble substances. This means that it has a low viscosity and is more likely to have effusive eruptions, where lava slowly oozes from the ground, creating floodplains similar to the moon's mares. Meanwhile, Uranus and Neptune's moons have lava with far more ammonia and methanol dissolved in the water, making it much thicker and more likely to form domes, like Mount St. Helens on Earth. The dissolved gases are also volatile, meaning they tend towards explosive eruptions. However, there are differences between hot and cold lavas, most notably the fact that, while solid rocks are denser than lava and so sink, ice floats in water. Although the mechanism that causes the cryolava to erupt is unknown, the fact that it does could provide an investigative opportunity for future missions to these icy worlds. Thanks for watching. Subscribe for more interesting content. Comment and suggest topics for more videos. Stay tuned.